So welcome to this session on shape and space. As I said, we're going to be looking at circles and triangles. And what I'm going to go through in this session is to understand angles, perimeter and area of triangles, know how to work out something and the area of circles. And I've covered that up because I'm going to ask you what that word is in a short while. So if I tell you now, you'll have the answer already. So something about circles, including the area. And we're going to talk about the formulas that you use. And that's one of the key things why people may say that triangles and circles particularly are maybe a bit harder in terms of shape and space and perimeter and area, is because you do use formulas. So I'll be covering those. One thing I do need to say, I'll say now, and I'll probably say it a number of times, is you are expected to remember these formulas, certainly at level 2. If you do level 1 functional skills, they will give you the formulas in the test. At level 2, they may give you the formulas, but you are expected to just know them. So these are things that you do have to learn and remember. And the final bit of revision might be the last 5 minutes cramming is to remember these formulas that I go through. As I always do, though, I'll ask you first, can you put in the chat how confident you feel about working out area and perimeter when we're talking about circles and triangles? 1 is low confidence, 10 is your highest confidence. And don't worry, if you don't want to share, you don't have to. And don't worry, whatever it is, if you think you know it all, 10 is fine. You're still welcome. And if it's 1, that's fine as well. So just put it in and keep that number in mind. And then when we come to the end, I'll ask you to review it, see if you know any more. And once again, we've got a few lower, not as many higher this time, and a few around the middle as well. So yeah, okay, well, that's good. And it's quite common. People do tend to worry a little bit about them. First question I'm going to ask you is, can anybody tell me in the chat any different types of triangles? They, not necessarily words that we use every day, type of triangle, any types of triangles they remember maybe from school or college or whatever it might be, the name of any different types of triangles. And I won't worry about spelling, don't worry. We've got equilateral, we've got isosceles. Anybody know any more? Them are the two that people seem to remember. Not spelled right, no. But that's fine. We're not worried about spelling. Acute and obtuse, very good, Paula, very well remembered. And there are others as well. I won't worry too much. The good news is you don't need to know. So as far as I can see, well, as far as I can tell from the functional skills, but level 1 and level 2 syllabus, there is nowhere it will say name this type of triangle, whether it be equilateral, isosceles, obtuse, right angle, whatever it might be. You're not expected to know them. If you want to know them, that's very good, and certainly do no harm to revise them, but it's not something that you need to remember that you're likely to be tested on. One thing you do need to be aware of is, and Stacey just gone right angle triangle as well, spot on. 4 different types of triangles there, and so I won't ask you to label them, but is there anything you notice that what was in there is the degrees of each of the points, the 3 points of the triangle? Anything you notice about those degrees, those angles within each of the triangles? Brilliant, a few people have spotted it already. Whenever you've got a 3-sided shape, a triangle, the angles will all add up, all the internal angles will all add up to 180. So if you look at it, 60, 60, 60 is 180, 70 and 30 and 80 is 180. And so internal angles will always add up to 180. So if you're given a triangle and it's only got 2 of the angles and it says, what's the missing angle? You know it's 180, take away the 2 that you've got. One thing I will mention just about this triangle here, what you do sometimes see, I'll draw it as straight as I can, is this called a right angle triangle because it's got what's called a right angle. The bottom left is 90 degrees, which is a right angle because the line goes down and then across. Here it's drawn, the arc is the usual symbol for drawing an angle. So you'll see here, it's got an arc with 90 on it. What you sometimes see is this square, if you look at the top one, this square that's sort of drawn there without 90 degrees. That symbol, that sort of broad square there, telling you is 90 degrees. So if you saw this, then you would know, and you needed to work out this missing angle here, you would know you've got 90 and 45, which gives you 45 for that missing angle as well. So something to look out for. You may be asked to identify the missing angle, and you see that one saying 90 degrees, then you can work it out for 100, but all of them would have 180. Perimeter of a triangle, some people have said it already. If you attended the session earlier, you'll remember that perimeter of a nice square or rectangle shape is adding up the outside, all 4 sides, and this is exactly the same, but you add up all 3 sides. So I believe, I was looking earlier, I'm not sure how accurate this is, but it seems strange to me, that road signs, standard sort of give way or warning sign like that is 36 inches, all 3 sides are equal, and the 36 inches. So to add up for the perimeter for this shape would be 36 add 36 add 36. Add them all up and you've got a perimeter. Yeah, that's all you need to know. 108 inches would be the answer. Again, we're working in inches.
We're losing
You add
you
all
a
three
bit,
sides.
Paul.
Say again, Sophie.
So we lost you a bit there. You froze on us.
Oh, sorry, I wonder what had gone. Yeah, so if you're adding a perimeter of a triangle, all you need to do is simply add up the three sides. So a bit like we were doing with a four-sided shape earlier, rectangle or square, the perimeter, if you know the shape, the length of the sides, you add them more. I was saying that a typical road sign in the UK apparently is 36 inches. So the perimeter, this would be 36 at 36 at 36, which is 108 inches. The area of a triangle is a little bit more difficult, and this is where our first formula is going to come in. So again, I'll draw it as straight as I can as a triangle. So we said earlier that area is the inside of a shape, so we need to know the space within here. Just erase that. And so let's give us a triangle. I won't give any kind of context to it. We'll just say that this triangle, you're given the measurements, is 6 centimeters across, and it's not quite to scale, is it? But never mind, and 4 centimeters high. You use a formula for working out the area inside the triangle. What you need to, the formula, I'll write it down and then we'll talk through it, is half BH. Half stands for itself, it is half. The B stands for the base, which in this case is 6. And H stands for the height, which in this case is 4. If you remember back to working on formula or our formula webinar, you will know when there's letters and numbers next to each other here and there's no symbol, there's no add, take away, times or divide, we always multiply. And the easiest way I think to do this is do 6 times 4, which is 24. And then you just want to halve it, which would give you 12. We were working in centimeters. And if you remember from the calculations we did earlier, it's area. So it's also given a little 2. So the answer is 12 centimeters squared. So the formula to remember is half BH, or half base times height, base height. And all that means is base times height, 6 times 4, and then halve it is the easiest way to do it. So you may see it written other ways. You can see it written BH over 2, exactly the same. But this is the way it's normally written, is half base times height. And the easiest way I would suggest doing it is doing base times height and then simply halving it. Just to show you why that works, so it might help you remember it. If I turn our triangle into a square, we said earlier that a square area is one side times the other, 6 times 4, which would be 24. And these shaded bits here are half of it, and we obviously don't want them. So all we're doing is taking half of it off, which would give us 12. And it doesn't matter what shape of the triangle is, it could be a right angle triangle or any kind of triangle. That's a straight triangle, is it? Whatever the shape, you will always use this formula of a half base height times the base times the height, and then half that number. So not too bad with triangles, not too bad to remember, I would suggest. A few people have put that in the comment already. Triangles are not too bad, but you do need to remember that formula. Oh, if I remove all of my writing off the screen, you can actually see. There we go. So half base height, do 6 times 4, and then halve it is the easiest way to work out the area. And remember the centimeters squared with a little 2. Circles are a little bit more difficult because circles have a whole language for themselves. So I'm going to draw you a circle here. Can anybody tell me that circle? I've drawn a blue line across the middle there. So obviously it doesn't matter where I drew it. This is in blue. It doesn't matter where I draw it on the triangle. As long as I go through the middle, it'll be the same length. Anybody tell me what that line is called? The blue line that goes across the middle of the circle. Well, Stacey's and Catherine's came through at the same time, so I can't give a bonus point for getting it first. But it is indeed called the diameter. So how about the red line? Now, again, the red line goes from the center to the outside. So again, it wouldn't matter where I draw it. It will always be the same length as a circle if it was a perfect circle. So I think, anybody tell me what the red line's called? And I can see some answers coming through already. Radius, very good indeed. So as you can probably see there, and seems quite obvious, the radius, if the diameter is all the way across and the radius is halfway across, the radius is half of the diameter. So if I said the diameter was 12 centimeters, the radius must be 6 centimeters. So the radius is always half the diameter. I'll explain in a little while why I've mentioned that and why that's useful. How about the green on the outside of the circle? So all the way around the circle, previously we've used the word perimeter. For a triangle, for a square rectangle, we said it was the perimeter. We use a different word for a circle. I'm sure there's a valid reason going back to Greek times. I don't quite know what that is. But yeah, a few people have got it that indeed the outside of the circle, all the way around the outside, is known as the circumference. In the other shapes, we call it perimeter. In a circle, we just call it circumference. So there's no difference between those. So going back to what I said at the start, there are formulas. There's a formula you need to work out the circumference of a circle, and there's a formula you need to work out the area of a circle. We have got a longer webinar on shape and space that goes through a little bit more detail about these, but I'm going to go through them relatively quickly here because the key thing is you remember the formula and are able to adopt it. So the formula for circumference is what's called 2 pi r. So I'm introducing a new symbol here, which looks a bit like that. It stands for pi, which is spelled Pi, not PIE. And pi is a consistent number that is to do with the relationship between the inside and the outside and the perimeter of a circle. Does anybody know a figure for pi, or a figure that they would tend to use for pi? I'll give you the answer. Great. So because circles could ever be ever more fine, if I drew this circle with a finer line, it'd be a slightly more accurate and slightly more accurate. Pi is actually an infinite number, just a decimal point to an infinite number of decimal points. We tend to use the figure 3.14 to 2 decimal places. As I say, it does go on forever, but 3.14 is the standard that we use for pi. In the test, once again, that is a figure that you're expected to know, and I see a few people in the chat have put that, which is really good. You are just expected to know that. Somebody's put 3.142, which is correct, and if you want to use the 2, you're welcome to. 3.14 would usually be okay. You often find some calculators have a button you press, and it will give you pi to however many decimal places you can fit on your screen. I know it has been worked out up to 1 trillion digits, and I say it's an infinite number, so it would have gone forever. You may, if you're using circles in a test, you may be given that pi is 3.14. Another approximation for pi is actually 22/7, which I have seen mentioned in a test as a fraction. 3.14 is 22/7. That's a lot less common we'll use it. We would usually use the figure 3.14. But if you see either of those, you'll know why. It is expected that you remember it, though. So if you remember it, great. If it's given you in the test, it's a bonus, but it is expected again at level 2 that you do remember that 3.14 is high. So now going back to our formula is 2 pi r. I said before, whenever you have numbers next to symbols or letters, you multiply them. So you would simply do 2 times pi times r, which I'm sure you can probably guess is the radius. So if our radius of our circle was 6, you do 2 times 3.14 times 6, for example. Key thing here is I mentioned it's using the radius. So going back to the left-hand side, I've said that radius is half the diameter. If the question in the test gives you the diameter, it's very tempting to just say that the diameter was 12, to just type in 2 times pi times 12, because that's the figure you're given. You do need to use the radius figure. So it's important that you do that. So if you are given the diameter, always split it in half first to make sure you always use the radius. So that's the one formula. The other formula you need to remember is for area, which is inside. And this formula is similar, but slightly different, same digits, but different round. And this is pi r squared. So we get pi times radius squared. Whenever you square a number, whenever you see this little symbol here, which means square, this little 2, it means you multiply it by itself. So radius squared is just radius times radius. 3 squared will be 3 times 3. 12 squared is 12 times 12, and so on and so on. So when we see radius squared, all that means is we times it by itself. So if you put our digits in, we know pi is 3.14. I think I said previously the radius in this example was 6, so times 6. And then we just times 6 again. And actually, it doesn't actually matter which order you do it in. You can do 6 times 6 and times 3.4. It doesn't actually matter however you do it in multiplication. But that is the formula to remember. So 2 formulas. You may have seen some of these before, since some of the people have mentioned them on the chat. So some people have seen them before. You may remember, may not remember them. It is expected, as I've said, in the syllabus at level 2 that you do know these formulas. So I would recommend a way, if you remember them, great. They are fairly short and they're similar, which is good. The downside is that because they're similar, it's easy to get mixed up. One thing that I do is whenever you have area, so if the area of a shape was 32, we know it would be 32 centimeters squared. We talked about earlier, is always squared for a symbol. And area has got a little squared symbol in it. So that's how you might remember that this one is for area, is because it's got a squared symbol in it, and you know the area is always squared. So pi r squared is area, and the circumference is the other one, which is 2 pi r. So however you best remember things, hopefully from practice. But the more practice you do, the better. But that might be something that you need to have a little note of, just somewhere that you look at regularly to remember that circumference is 2 pi r and area is pi r squared. Right, what I've done in other calls is work through some examples with you and then got you to do them. We'll just go straight into it if that's okay. I'm going to give a couple of practical examples that you may get. So we're going to practice circles. And the question here, and I've sort of taken a step forward, but the question is, how many full rotations of this wheel have made if it travelled 3,500 centimetres? There's a wheel in the car travels 3,500 centimeters, and we need to know how many times has the circle of the wheel gone round for that. So looking at this question, the first thing I know I need to work out, because if I need to know how many times the circle has gone round, I need to know how far it is all around my circle, which we said is called the circumference. So I need to work out the circumference of that circle. So can any of you, please, in the chat, work out the circumference of that wheel? The circumference is all the way around the outside. Can't remember from the last slide. I will tell you the formula for circumference is 2 pi r. I'll give you a couple of minutes, see if anybody can come up with the answer. As always, if you haven't got time to do this now, you're a little bit unsure, you want a bit more practice, we have got plenty of examples that I can send you of these, and we'll send you some follow-up questions as well. So while some answers are coming in, I know the formula is 2 pi r. I know 2 is 2, pi is 3.14, and the radius, in this case, it tells us the radius. It hasn't given us the diameter, it's the radius. So I know it is 2 times 3.14 times the radius, in this case, 27.5. And if I multiply them together, I get 172.7. So you may have rounded that up, you may have rounded that down a little bit, or whatever it might be. Again, I said pi is 3.14. If you use 3.142 or a more accurate number, you might get a slightly different answer. But the answer of 172.7 centimeters would be appropriate here. So that's working out the circumference. The question, however, asks how many full rotations will the wheel have made? So can anybody think how they would work out the number of rotations this would make if it's travelled 3,500 centimeters, and what the answer to that would be? Brilliant, Shahida. We need to do some dividing. Can anybody do that? I would recommend probably a calculator for this one. This would be a calculator question. We've got answers coming in. Correct calculation, Stacey. So if we know that the vehicle is travelling 3,500 centimetres, and we know one circle goes around 172 centimetres, we need to know how many times does that 172 centimetres fit into 3,500. So as some people have said in the chat, what we do is 3,500 divided by 172.7 means the wheel would have done 20.27 rotations. Just thinking about exam technique here, it does say the question, how many full rotations will it have done? Well, that actually means it will have done 24 rotations and 0.27 of a rotation. So actually the answer here is 20 rotations. It is 20.27 rotations, but the number of full rotations are 20 rotations. So a couple of things there. So we've done a proper practice type test question there, but you work, the key that I wanted you to take away from it is working out the circumference. Got another practice question. And so this is looking at combined and irregular shapes, which we did with squares and rectangles earlier. And I said, when you've got that, let's keep it as easy as possible. So we've got a shape here, and again, I won't put it in context, it's just a red circle with a yellow triangle inside it. And I'm going to tell you the diameter all the way across the middle is 12 centimeters. And what I want to know is what is the area of the, what is the size, sorry, of the area that's shaded in red. The way I would suggest that you approach this is the first thing you need to do is work out, well, what's the area, the total of the area of the circle. So you can see the circle there, and we want to know the area. Whilst you're working that out, if you can't remember, I'll remind you that the formula for working out the area of a circle is pi r squared. And there was something that I warned you to look out for that I've purposely put in this question, if you can work that out and spot that issue. Some answers coming in. We know that pi is 3.14. And the key thing here, again, we need to use radius squared. And if we look at the bottom, I've given you the diameter. So if the diameter is 12, the radius must be 6. And we said to square it is you just times it by itself. So the calculation we need to do is 3.14 times 6 times 6, which some people on the chat have said gives us 113.04 centimeters squared, which is key. We now want the area not including the triangle. So what we need to do really is work out the area of the triangle next. So if I erase some of the text, and if you remember the area for the formula for working out a triangle is half base height. Probably not super easy to see, and it may not be quite, well, it's certainly not to scale, is if the diameter is 12, that means all the way across there, and all the way up is 12. So the diameter, the base and the height of our triangle are both 12. So we need to do half times 12, which is the base, and 12 again, which is the height. Wait for some answers to come in. We have our first submission. Great, a few more coming through. So, yeah, that's, yeah, just looking how some people have got their answer there. I've put the wrong answer in here. That's my fault. I was doing that just to test you, I promise. So it is indeed half 12 times 12. Best things always go wrong in live sessions. And you're right. I think I'm doing that in my head, and I'm pretty sure you're right. 12 times 12 is 144, divided by 2 would indeed be 72. So you can ignore me completely there, because I've made the mistake. I'd like to blame someone else, but it wasn't anybody else, it was me. So let's erase all the ink. So this answer should actually be 72 centimeters squared. It panicked me when I saw the results coming through there. I'm thinking, I'm sure I have used radius, Louise. As I said, I did it on purpose, really, just to check that what you were doing there. So 12 times 12, and then half it is 72. If we want to know the area, the shaded in red, we know the total circle is 113.04. And we know the triangle now, we now know is 72. So all we need to do is take that away. And I need to do some quick calculation because I got the wrong answer. So 113.04, take away 72 gives us 41.04 centimeters squared. Again, remember, because we work in centimeters, we need to stick with that calculation. So few people have got that. I didn't get it, but you did. Very good. So great. So we've worked a couple of examples there. The things I want is the key thing I want to take away from this webinar is to remember the area of a triangle. The formula for that is a half base height, or half BH, or sometimes written BH over 2. The same answer, but it's base times height, and then basically you want to halve it. The pi, as mentioned when we're using circles, and pi as a figure, we would usually use the figure 3.14 to represent pi. It is 22 over 7 is the fraction equivalent to it, so you may see that, but pi we would normally use 3.14. If in the test it gives you a figure that's longer, and the key one that often uses 3.142, if it does give you that in the test, I would suggest using that figure. But if it doesn't, if it just says use pi and it doesn't tell you what the figure is, 3.14 should be adequate. The formula for the circumference of a circle is 2 pi r, which means 2 times pi, which I figure we just talked about, times the radius. And remember, if it gives you the diameter, you do use the radius. And finally, the formula for the area of a circle is very similar, but it does give you a different result, and that is pi r squared. So those three formulas and the figure of pi, you are expected to know and to remember in the test. Those are ones that you need to just purely revise and then put into practice. One thing you can do in the test is once the test timer has started, you are welcome to write down those on a piece of paper. So if you want to remember them in your head, sit and get the test, and when they say, right, the test has started, and you press start, your time ticking away, you can note them down on your bit of paper. You obviously can't have them written down to go into the test, but things like that, if you need to remember them, then you can write them down and start the test.